Okay, so now we're going to move on to example 27. Find the accumulated value at the end of 6 years of an annuity for which semi-annual payments of $2,500 are made, starting 6 months from now if the money is worth 3.3% compounded monthly. So first thing we have to do is we have to make our timeline to figure out what's going on. Okay, so we have accumulated value, so that tells us we're doing some type of S sub n. And then at the end of 6 years, so we know this is a 6-year mark, and this would be our S sub n, for which we have semi-annual payments. Okay, semi-annual payments tells us that our old is 2, and that we're having these every 6 months. Okay. And the payments are made not now, but 6 months from now. So we have one here, and one here, and the money is compounded monthly. Okay, so that's our problem. So our old frequency is 12, and our new frequency is going to be 2 because we're converting a monthly to, okay, so we need to convert monthly to semi-annual. Okay, so that means our old is 12, our new is 2, so that tells us that y is going to be 12 over 2, so 6. Okay, it also tells us that means that our effective interest rate is going to be 1 plus 0.033, because that's our R, over 12 to the 6 minus 1 would give us 0.016613, and that's going to keep going. So this time, because we're going to use that as part of our problem, we're not going to round it. What we're going to do instead is we're going to store this as a letter. Okay, so you hit your store button, which in this case is, I'll show you on my calculator, it's right here. Okay, right here, this STO button. So I'm going to write going to click STO. Okay. And then I'm going to store that answer as A. Okay, so now that's my A. So that means next time when I recall it, I can just write A in there as my interest rate. So now we have to figure out our N. How many payments do we make? Well, here we make 2 payments a year for 6 years, so we have 12. We're finding it at the end of 6 years, and we're not told it's moved at all, so that means we're trying to find S12. So here our regular payment is $2,500, so we get 1 plus point our A, sorry, it's not going to be anything, A to the 12 minus 1 all over our A. So that's a little weird to enter in the calculator. So I'm going to show you how to 2,500 times, and then we need a second set of parentheses because we're doing S sub A, so 1, and then we have our plus, and then we're going to use our alpha A. Okay, so 1 plus A, we're going to raise that to the 12, subtract our 1, and then we divide that by A. Okay, so then this is our S sub n, and we get 32,898 and 93 cents, because we would round again to the nearest penny. Penny, remember, is the second decimal place. This is our answer. Go ahead and go on to number 28. Number 28. So a real similar problem here. So I'm going to go ahead and clear out our calculator so that we're ready. So for number 28, okay, we're going to do 28. So find the size of periodic payment. Okay, so here we're finding R, that a couple would need to make in order to accumulate $62,000 in 12 years, making payments at the end of each year. So which pays it quarterly. Okay, so again we have to start our piece here. So we're doing 12 years and we're figuring out how much we pay at the end of each year. Okay, and then into an account that pays 7.7 interest quarterly. So we need to convert a quarterly rate into a annual rate. So that means our new is 1, our old is 4, so that tells us that y is 4 over 1, or 4. So our effective interest rate is going to be 1 plus 0.045, because that was r from up here, over 4 to the 4 minus 1. And when you do that, you should get 0.045765. Okay, and again, we're going to store that as our A. Okay, and then over here we have 62,000. So again, this is an S sub n problem, but this time we know what S is. It's just S12 here. So S12 is equal to 62,000. Okay, and that's going to be equal to R times 1 plus A to the 12th minus 1 all over A. Okay, so then we could also write that as R equals 62,000 times A over 1 plus A to the 12th minus 1. Same process. When you plug that in your calculator, you should get 3,991 and 66 cents for your R.